Ooh-wee. Okay. Trying to make some progress. Oof. Oh, yeah. That's handy. This is helping. Okay, cool. Okay. I'm gonna account for sometimes if interested parties take a while to pop up. But if I end up ending the stream and nobody makes it, not a worry. That would not be the first time that's happened. Let's see if I can do a custom timer. Okay, cool. So we're gonna do 35 minutes. That should help in case if there's any stragglers. But if nobody shows up, nobody shows up. Alright, the timer's set. So, we're continuing on over there, deploying the software. And I was just thinking, oh, I wonder how much I have until the next chapter. Not much. Yay. Alright, deploying the software. During the design process, you can create a diagram that shows how your software will run and will be configured on the final computer system. I kind of wonder what the adjustments are for apps, like Android apps and the App Store. Do they call them apps? Whatever, things you put on iPhones and stuff. And while the diagram you use is called a deployment diagram. This is a static diagram because the information in it does not change while the application is running. Figure 3.9 shows an example of a deployment diagram. Okay. Then it says, in this figure, we've included 2 nodes in a hardware system. A node is any computer component. In this case, one node is a PC, and the other node is a shared drive on the network. Okay, hello people. Thanks for coming by. Reading time. I've got a timer ticking away. I am real close to chapter 4 for this particular book, in this big book. Alright. I see you, Lowrance Gaming TV. What have you been playing lately? So, other nodes share drive on there. Okay, you can see in a diagram that the shared drive contains the 2 DLLs. The executable itself, however, resides in the user's PC. Note also that the components have connections between them because we use the same case model that we used in figure 3-8. When we added the components to the 2 nodes, the case tool automatically drew the lines to connect them. I still don't know. Oh, hi, I play Roblox. So, and also hi, HP edits. But yeah, I still don't okay, so I was looking up, and apparently, so this is the 3rd edition, but if you look up the title, if you Google it, there's a latest edition. I think it's the 4th edition. So I have to wonder how how this gets varied, some of these things. Boss man? I don't know about all that. I swear, this year has just been wild. I keep thinking I should be going in the right direction. Hi, Leon. And I don't know. Alright, so in this case, I don't know. Some makes me wonder. Because case, that's why I was thinking about that. Case, I don't think that's a thing anymore. That is used anymore. So it's like, okay, so then if that's not used anymore, how do you do these wonderful things via software? I don't, Leon, I'm a little confused. If you're saying I am reading, that's true. That's what's going on. Um, if you said well read, okay, possibly. Okay, but the color red is red, and also there's that's like a white, and this is a green and a blue. So I don't know. Okay, so I keep. All right, this is a little less messy, so we'll see if this goes anywhere. So if I flip this, every time I think it's flipping, it's just getting closer. Okay. Oh, okay. That's a nice vibe. Okay, so here is the figure. Oh, this table is handy. Okay, I was doing some training for my job that just started, but like, oh, this does help for this part. I was having a hardest time trying to hold this book up yesterday with just using the bench. Anyway, so if you look, it says figure 3-9. This deployment diagram has two. This supposed to say really modes or nodes? I don't even know right now. I think they meant nodes because everything like in the paragraph was talking about nodes, but whatever. So this is the shared drive. Oh yeah, it's nodes because they were talking about the shared drive being one of the nodes and then the PC being the other node. And so effectively you can see that the shared drive is composed of the DLL, which is the accounting library, which we discussed last night is a stereotyped DLL, and that's another stereotyped DLL. And effectively a stereotype in the case of C++, or at least the UML, I think it's the UML, means you can take an existing UML and you can modify it. And then effectively the thing that you changed becomes your stereotyped thing. So this is a regular DLL, but there's some special thing that makes it for the accounting library. And this is another DLL, but some special thing that makes it for the math library. And the way that you can determine that is stereotyped is because you see the two left things. So apparently the PC also has a stereotype of the executable, and it's, in this case, a Spike program. So the Spike program is dependent on the DLL and also the accounting. So then it talks about 3-10. And it says you can be creative when designing your deployment diagrams. So they're talking about a Mac Pro, an Dell XPS, A700, and both of them get linked up to this HP OfficeJet Pro 8600. Okay, so back to reading. Okay. So it says figure 3-9 shows an example of a deployment diagram. In the figure, we've included two nodes. Oh, okay. Sounds good. That's a good one. Chris R. Let's see. Oh, let's see. Figure 3-9 shows an example of the deployment diagram. In this figure, we've included two nodes in a hardware system. A node. Okay, we remember that. The executive itself, however, resides in the. Okay, we remember that. One particularly fun aspect of designing deployment diagrams is that the UML standard lets you make your own versions of symbols. However, this creative capability goes beyond just stereotyping. When you add a word inside those funny looking angle brackets. Huh? Am I? What? Did I miss something, does it have to have the words to be considered stereotyped? Oh, yo, sorry. My apologies. Yeah, it does have to have the words. So the fact that they are no words, that means they're the components. Oops. All right. So if the words were there with the little symbols, that means it was stereotyped. Okay. Gosh. You would think I would have not made that mistake. I literally just read that not, like, a little over 24 hours ago. Alright, whatever. One particularly, however, this creative capability goes beyond just stereotyping, where you add a word inside the funny-looking angle brackets. Instead, you can actually use clip art. Yes, clip art. Take a peek at figure 3-10 to see an example. So in this case, this was the clip art that they were talking about. So just pictures of, that's really cool. That is a good way to do that. That way it makes it very clear. And then, yay, that is it for chapter 3. So chapter 4, let me check my time. Alright, cool. Alright, so this is book 2, chapter 4. Demonstrating behavior with UML. In this chapter, we're going to cover drawing out objects in UML, expanding use cases into use case diagrams, ordering steps with the sequence diagrams, showing how objects collaborate, noting the flow of activities, and stating the different states of an object. In this chapter, we walk you through the 5 dynamic diagrams in UML. So the other chapter is all about the static. Those are the things that don't change. And now this is those things that can change. Such is life. In this chapter, we walk you through the 5 dynamic diagrams in UML. These are the diagrams that show how objects work together and change over time. Some of them you may find more useful than others, and that's fine. You don't have to use all the diagrams you see in this chapter. You're free to use those that you find the most useful. Drawing objects. In UML, you can draw class diagrams that show the class in your system, or you can get right down to it and draw an object diagram, which contains actual instances of or objects. Because you're drawing instances, you might have multiple objects of a single class on a single object diagram. Oh yeah, that's looking familiar to what I learned about in advanced object-oriented programming. Remember, when you draw objects on a UML diagram, they look pretty much the same as class diagrams, but with one important difference. For an object, the name at the top of the rectangle is underlined. With classes, the name is not underlined. Be sure to remember the difference so that your diagrams don't confuse other people. The best way to explore an object diagram is to see it compared to a class diagram. Take a peek at figure 4-1. You can see a class diagram at the top and an object diagram at the bottom. Okay. I don't know why that does that. It's like, I'm trying to flip it and it's like, no, you must want your face nice and close, right? Well, this is my face tonight and not my face like yesterday. Okay, so in this case, it says figure 4-1, class diagrams and object diagrams are similar. So there's the class diagrams. So notice here's the box, and then there's the name of the variable and then the type of that with the colon separating them. And then with the cow, and then you can see that this is the diamond, the closed diamond. I forget. I'm always reading what the diamond means. All right. Google it. Closed diamond, C++, UML, what have you. Closed diamond, UML, probably that one. Yeah, or you can just, yesterday I talked about it. This one with the asterisk, I remember that means that is some number Um, there's really no set number to it. It pretty much is any number. And then, so some number of cows can go into a pasture. So the weight is a I believe you call it a feature. And that is type, and it's set to equal of 600. The age is also some number, in this case the type int. That's equal to 3, and the name is a string equal to Bessie. Oh, okay, so this is just Bessie the cow. Oh, that's fine. And then that says hi cow. Okay, so that. And then this is Rolling Hills of India pasture. So this is a type, or effectively, this is the pasture general. This is the cow general. This is the specific pasture, and these are specific cow 1, specific cow 2. So they're saying effectively, you can see there's connections and relationships that are established. Same with there. There's information, but the main thing that they were just pointing out is that this is not underlined versus that's underlined as the object. All right, so then two classes are in the diagram. The names are not underlined, and the two classes are related by composition. Oh, I think that's what the diamond is. The composition is one to many. One pasture instance to multiple cow instances. For example, in effect, instances of the pasture class contain 0 or more instances of cow. We've included some attributes for each class. The lower half of the diagram shows instances of the classes. When you program, you sometimes give a name to an instance in the way of a variable name, or you may be using a language that allows its objects to be named. C++ does not allow this. You have to use a variable name. In the object diagram, we named the instances. At the top of each rectangle is an underlined name, a colon, and the class type. Thus, Rolling Hills of Indiana is an instance of type pasture. Bessie is an instance of type cow, and Hilda is also an instance of type cow. Inside the object boxes, we also give values to the member variables or attributes. For these, the name goes first, and then a colon, and then the type, just as in the class symbols. But then you see an equal sign and a value. Because these are actual instances of the class, they can have values for the member variables. Look carefully at the line connecting the Rolling Hills of Indiana object to the Bessie and Hilda objects, as well as the line connecting the two classes. You can see an arrow pointing to each of the cow instances, but not to the pasture instance. Thus, the pasture instance contains a pointer to each cow instance, but not vice versa. That means the cow instances don't know about the pasture instances. That is, the cow instance does not contain a member variable that points to the pasture instance. You can see this is the case also with the class diagrams because an arrow is pointing to the cow class. So effectively, if they knew of each other, you'd have an arrowhead on this side and that side. Remember, I'm trying to think if there's like a not filled in version. It's been a bit. Remember, that's why I'm doing the review. If you want, even the review needs a review sometimes. If you want both instances to know about each other, you simply remove the arrows and use only lines. Okay. So effectively, you could have the two arrows, but it's fine to just not. This is called a bidirectional association. When you have an arrow, it indicates that the relationship is unidirectional. In the case of pasture and cow, the arrow indicates that the pasture instance can call methods in the cow instance, but not vice versa. Cow methods eat, go potty, moo, I don't know. Um, the cow instances are not aware of the pasture instance. Sometimes people really like to show that the objects are instances of the class by drawing a dashed arrow from the instance to the class and adding the instantiate stereotype. When you have lots of instances, this technique can make for a messy diagram. But you have only one instance per class, you can easily show it in the diagram. We did just that in figure 4-2. Notice the word instantiate is present and that the arrow points to the class. To us, the setup seems a little backward, but lots of stuff seems backward in the world of computers, so we're not surprised. True. All right. Okay, that's... Why does it do that? It's like, please, I'm trying to flip. No, okay. All right. So, just this is the diamond. I guess I can stop being lazy for a second. Let's see. Going back to refer to... Okay, here's a previous diamond. So, let me see. Okay, this is the non-filled diamond, and that's when they're talking about aggregation. That's what it is. So when it is filled in, that means composition for sure. And when it's not filled in, this lovely diamond, such as this, that means aggregate. So in this case, yes, this is diamond is filled in, so that means it's a composition, which is what I was calling out when I was reading it. So at least I remember that part based on what they were saying again. What else? Oh, the dashed. These guys are the dashed lines with the instantiate versus here, where it's a little bit more concise and easy to see what's going on. Again, what they're saying is this is perfectly fine when you don't have a lot going on. But as you want to end up, especially when you're me and you don't know how to like not overdo things, you kind of want to keep things very easy to tell what is going on. So this is going to be my go-to, because knowing me, I'm going to have too many things going on. Just as typical. All right. And in case anyone's wondering, yes, eventually programming is happening. I just gotta get this book, and hopefully my computer can deal with it. It's on its way out. I just I don't expect to have any way to replace it anytime soon. So it's gonna be a struggle bus, but that's pretty much been the year 2024. So all right, so then it says all of that loveliness. Great. Now it's casing out the use cases. Talk about disagreement. People have argued and bickered about use cases for years. The term use case, pronounced with a soft S as in use, it's just like, oh, right, I know how to say this, because anyway, because use is a noun here, refers to one single case or instance of functionality in your application. Most applications have many things you can do with them. For example, a web browser enables you to click the Go button to go to a web address that you've typed into a box, or enables you to click a link to go to a page. Each of these two things is a single use case. Use cases have become an important aspect of modeling software. So why the contention? Because use cases focus on the functions, that is, verbs, of a software package, and objects focus on the things or nouns. So it would make sense by that argument that use cases have no big place in object-oriented analysis and design. However, the flaw in this argument is in saying that the term object-oriented means that you focus only on the nouns. It's true that it's oriented to the objects, but that doesn't mean you ignore verbs or have a disdain for them. Personally, we like verbs. Life without verbs, boring. Talking, difficult with no verbs. Me, car, grocery store. And the same is true with object-oriented programming. Although we focus our building around the objects, we still have functions, which are verbs. And we still have functionality, and we can organize and group the functionality, such as through menus or through dialog boxes. Alright, let me check it. I'm surprised nothing new has come up. Just under 10 minutes. But nothing new has come up on the chat. Okay then. And so when we design software, one thing we do is review the usage environment and list all of the use cases we can think of for the software. This often takes place in the analysis phase. Figure 4-3 shows an example of a use case diagram. The actual use cases are the oval shapes. And you've certainly noticed the other goofy symbol, the stickman figure. Okay. I just don't understand why that does it. Okay. So, they're talking about figure 4-3, this guy, as a use case diagram shows the functionality of the system. So the stick figure saying patron, and then restaurant, you can order food and eat food, and you can pay for food is the main things that they're listing. Alright. The stickman figure is called an actor because it represents the user interacting with the application, similar to the way an actor interacts with the audience. Yes, this is one time when we, the software engineers of the world, get to revert to our childhood roots and draw pretty pictures. In this case, we get to draw stick figures. Now, just to be crystal clear, please realize that this is a unisex stick figure. It is neither a man nor a woman, nor both a man and a woman. Thus, we don't need to draw a skirt to show a woman, as so many other fields do. Here, we believe that all people are, at heart, all the same. Thus, we draw our stick figures all the same. Now, if you look at figure 4-3, you can see that the use cases each have names. These are the things that the user can do with the system. We use the word system to mean a collection of software that you're building. The system in this example is called restaurant. Me? Okay. Captain Fantastic. Okay. Officially, I'm maybe, sort of, maybe, probably all done with studying for anything to do with computer science because I just in May got a master's degree in science, master's of science in computer science, and I don't expect, unfortunately, to be able to be in a position to be able to pursue a PhD. So that'd be like super awesome and wonderful. So currently, I'm just kind of reviewing C++ because it's something I got an opportunity to, that and C Sharp and C. Um, got a chance to do some learning about while in the thick of things, but didn't really have proper time to sit down and digest. So I'm kind of just doing some fun times on by myself, working on some projects, and then maybe one day it might be something where I have like a portfolio I can show potential employers or clients or PhD people like, hey, why I would be a great fit for your school sort of deal. I don't know. Right now I'm just kind of just having some fun, reading a book for a little bit till my timer goes ding ding ding. Now if you look at figure 4-3, you can see that the use cases each have names. These are things that the user can do with the system. We can use the word system to mean the collection of software that you're building. The system in this example is called restaurant. The actor represents the user of the system. In the case of a word processor, that could be you sitting there using it, or it could be another human. Either way, it represents a user, a human being. For now, I don't know. The lines point to the different use cases the user has access to. Okay, so they do, anytime they try to like, at the very least when they try to like break it out like that and make it separate, I'm like, oh, maybe you're interested, potentially. So this is a section that they constitute as their use case order food. And if you notice, it's got the ID, it's got the actors, it's got the preconditions and the flow of events, and there's 6 of them. Then it's the post conditions. And then there appears to be, actually no, there's 9 of them. 9.1. Then there's 9.2. Oh, there's a lot going on with that. The point is, there's 1 through 6, then you go to the top right, then it's 7, down to 9, which 9 is broken down into a few things. And then a post conditions is on the bottom left, I guess, because that's the only place that fit. All right, cool. Okay, so it says, use case order food. Ordering food is a handy and tasty example of how events flow in a use case. ID UC 1000. Actors, patron, preconditions. Patron must be seated at the table with a napkin covering clothing. Hands must be clean. Flow of evidence. The patron waits for the server to arrive. 2. When the server arrives, the patron orders the food. 3. The server takes an order to the kitchen. 4. The cook prepares the food. 5. The server delivers the food to the table. 6. The patron eats the food. 7. The server asks the patron whether dessert will close out the evening meal. 8. If the patron wants dessert, 8.1. The patron looks at the dessert menu. 8.2. The patron chooses a dessert. 8.3. The server fetches the dessert. 8.4. The patron eats dessert. 9 else. 9.1. The server relaxes for a moment, dreaming about what life could have been like if dessert had in fact been part of the evening meal. Steps 1 through 9 can easily be a function or an algorithm if you also use for loops and while loops by putting the for or while condition and following it with steps. In this case, they talk about 9.2. For each dessert on the menu, the patron imagines 9.2.1, eating a single bite. 9.2.2, contemplating the flavor. 9.2.3, devouring the rest. Post conditions. The patron has a full stomach and is ready to pay for the food. For some steps, you may have what amounts to an if-then-else block in your code. You can notate this in different ways, but here's a handy one. The flow of events goes beyond step 6, like this. Oh, I had it right the first time. Oh, those were the post conditions. Oops. Okay, so effectively, one patron waits for the server to arrive. When the server arrives, the patron orders the food. The server takes the order to the kitchen. 4 was the cook prepares the food. 9, the server delivers the food. 6, the patron eats the food. Then the post conditions. That involves the whole thing about the server. Okay. Expanding use cases. After you draw your use cases on the diagrams, you can define what they do on paper. The way you do this is to write the information in a single column table, with each row specifying different information about the use case. This information includes the name. Oh, I love this because oh, see? Anyway, the name of the use case as you described it in the diagram. Unique identifier, special code that some people like to include, such as UC, which stands for use case, followed by a number such as UC 1000. The actors involved with the use case. Preconditions. The situation that must exist before the use case can begin to operate. Flow of events, a step-by-step flow of events that take place when the use case runs. Post conditions, the situation that will exist after the use case runs. A sample use case. Oh, bummers. And also great timing because I'm almost done with this section. Okay, I'm out of time, but I'm also done with this section. So yay, that's rarely does that happen. A sample use case makes an exclusive guest appearance in the earlier sidebar use case order food, which I think we already discussed. So that's where I'm putting a pin on it just before this title here, picking up on that next time I do a live. I don't know if it's tomorrow or not. I wasn't really planning on doing one today, but I needed a chance to calm down a bit because new work sort of job stuff training. So thank you so much. It was very nice to take some time to just enjoy some C++ with you guys. Thanks for everybody who was able to just come in, even if you just was like in and out. Appreciate you having interest. Anybody who checks this out later is possible. I don't know. This is a quicker video, so it should be less of a processing time. So, that being said, if you're at all interested, please feel free to subscribe. I do start recently the C++. I'm gonna get some coding in the mix at some point. I've also been doing YouTube shorts, mainly dancing. I'm hoping to actually develop some software that's going to, at least in part, pull videos and information from both YouTube and TikTok. I also have dance videos on TikTok. Very different and totally different things. So don't be like, oh, well, I'm not going to be interested in the TikTok, even though I kind of like your YouTube dancing, because it's going to just be the same thing. Actually, no. At this point in time, it's all distinct. I have a set TikTok, and then I'll do a set YouTube, or a set YouTube and then a TikTok, blah, blah, blah. This is Halloween. I'm trying to get the Halloween type things going on. With all the like new stuff, I just haven't really been in a dancing film. Plus, I kind of overdid the dancing on Sunday. I'm trying to give my neighbor a bit of a break. If you're interested in older things, I do have something on YouTube. Some older dancing that was orange shirts, shorts. I have some reviews of me doing Once Upon a Time. It could be a spider. That's very possible. Hopefully it's not too scary and also Halloweeny. So I think that's what you're talking about, yeah. So unfortunately, I'm very financially not able to really get into the entire pageantry of Halloween, unfortunately. The best I can do is just find some Halloween sounds and do some I'm calling them improvisational dance. Some people are saying they are, interpretive. Some people might say freestyle. I don't very much know. I just kind of go with it because I don't have the kind of schedule where I could sit and learn choreo. Really don't. All right. So yeah, Becky828, TikTok, here. Subscribe if you like. I have no set schedule. You're welcome for the stream. Pyrex, I believe. Um, Thanks for coming by. Very nice, cool way to just calm down a bit because, I don't know if this job's gonna work out this year even. Hopefully, oof, hopefully. I don't imagine it past this year though. That being said, I'm gonna go. I'm thirsty and hungry, and I need sleepy times so much. So dancing, coding, eventually, book reading, continuing later, maybe soon. Anyway, bye bye. Thank you.